Alright guys, so you can try this question and you can resume for the solution. Now you have to be very careful what the question is asked actually. So the question is asking f of g of x plus g of f of x. This whole thing find f of. Okay, this is our question. At x equal to 1. So technically we are required to find f of g of 1 plus g of f of 1. This is our question. Alright, so let's solve. We have been given f of x is equal to x square, guys. In this, if I substitute x is equal to 1, I will get f of 1 is equal to 1 square, which is equal to 1. So this entire term I can simply replace by a 1. Similarly, g of x has been given as 2 raised to x. So in this, if I put x is equal to 1, I will get g of 1 will be equal to 2 raised to 1, and that is 2. So g of 1 in place of g of 1, I can simply substitute a 2. So now this entire expression here, this boils down to f of in place of g of 1, I'll put a 2 plus g of in place of f of 1, I will simply put a 1. Okay, this is our next step. So now the entire expression is f of 2 plus g of 1. Now f of x is x square. So f of 2 will be realized when you put x equals to 2. When you put x equals to 2, f of 2 is equal to 2 square, which is 4. Similarly, when I put x equal to 1 in g of x, I will again get g of 1 as 2 as already found. Now I substitute both the values. This entire expression would become f of 2 is basically 4 plus g of 1 is basically 2. So finally I would be needed to find the value of f of 4 plus 2, and that is f of 6. So my final step here is to plug in the value of x as 6 in this particular equation. When I do that, I will get my answer f of 6 is equal to 6 square, and that's nothing but 36. And as you can see, this clearly matches with the C option. And that's the answer to our question, option C. Simple question, just 2-3 steps. Using composite functions, you can solve this.